Hello, everyone. My name is Darius, and I'm a senior software engineer at Samsung, where I work on the Eclipse DDK and as part of DevTech, which is developer technical engineering support, where we collaborate with different companies and help them get the best performance of their games on Android devices. Today I'll be talking about Swapchains in Vulkan and how to manage them effectively. During our collaborations with a lot of gaming companies, over and over again, people came to us with the same issues of how do we deal with Swapchain? We can't get it right. Please help. And I will try to help. Maybe someone can get something useful out of this presentation. I will show some of the common pitfalls that developers fall into, and I will try to explain how to avoid that. So the content, what we'll be talking about today. First of all, Swapchain. We cannot really talk about how to deal with Swapchain without first getting everyone on the same page on what it is. So we'll just get on the same working definition. Then I will briefly talk about pre-rotation, just what it is, why it's needed on mobile devices, and how to deal with it. Also, why no one really does it. Then the maintenance of Swapchain, just how can you work with it, and what extensions are there to help you. And as a bonus, if we still have time, I will go briefly over frame pacing and how to reduce power consumption and frame stuttering. I do realize that this is a lot of material and we might not be able to cover it all. It's basically at least an hour worth of content that I crammed into 25 minutes, and I will be skipping a lot of parts. And luckily yesterday it was already established that it's fine to lie. So yeah. If anyone wants any more information after the talk, please do find me and I will try to explain some more stuff. Okay, so Swapchains. We will here look what it is, why it exists, and yeah, how it communicates with different parts of your engine. So before we start, let's just quickly consider how we get data on the screen. So we have the rendering engine, which turns your data into a presentable image, and the presentation engine that gets it to the screen. Swapchain is the thing that leaves. Where is my? Okay. Well, whatever. Swapchain is the thing that lives between the rendering engine and the window buffer in this graph. It helps you synchronize your images between the rendering engine and the presentation engine. So first, glossary. For those people that don't know, in Vulkan spec, there is such a thing as glossary, where you can find a lot of useful information on what things are. So first of all, I already said presentable images. What are those? Those are just Vulkan images associated with both Swapchain and the surface. Then the VK Swapchain. It's an abstraction. So it's a handle to the array of presentable images that are associated with a surface. Like Swapchain has a read and write privilege, but not a create and destroy privilege of the memory. This is important when destroying Swapchain, because that means that your memory deletion might be deferred until later. Then we have the VK surface, which is another Vulkan abstraction. This is just a handle to the underlying window. This one doesn't hold any resources itself. It's just a handle that lets Vulkan communicate with your window. And then the retire Swapchain. In most cases, only one Swapchain can be associated with a surface at any given point, except when you recreate your Swapchain and pass in your old Swapchain. Then the old Swapchain is still alive at this point, it's considered to be retired now. You cannot acquire any more images from it from this point on, but you can still present images that you have acquired before. So Swapchain ownership is a bit complicated, especially since ownership can mean a lot of things to different people. Vulkan application only acquires images from Swapchain. Those are created internally, most likely by the presentation engines, but there are some exceptions. Let's not talk about them. Here, I just want to note that since destroying the Swapchain doesn't invalidate the surface, you do not need to destroy your surface whenever you want to recreate your Swapchain. So what does the presentation engine do? In a very abstract way, and just to give you a very high overview, what it does, it gets the image from your process, it will compose it, get it into the final frame, and then get it to the screen. It can do composition in two different ways. First is the GPU accelerated composition, which again I cannot show it with my mouse, but it's the top one where you have the window buffers being composed into composed frame buffer. This is the equivalent of doing a render pass and just composing two images. And the other composition is the scan out hardware composition. This one is a lot faster because it's literally composing images as it scans them out. But as an application, you do not always have all of the information on how to achieve that. So that was the logic of what the presentation engine does. And now some synchronization. Only one entity can hold any given resource at any given point. Either rendering engine holds it for rendering, or presentation engine holds it so it can compose and present. Both rendering engine and the presentation engine can, and in most cases will, hold more than just one image. If you consider presentation, present engine is not able to release previous image until it gets the new one, because otherwise it wouldn't be able to do composition with other processes. Okay, now a quick brief overview of pre-rotation. All of the non-mobile developers can fall asleep for a quick second now. And I know it's been done to death. For the last 8 years, people been telling you, whenever there's some developer with mobile background, he gets on the stage and talks about the best practices for mobile, they just say, oh yeah, you need to pre-rotate your images, just do it. But usually you don't get really why, how, and just like, what do you want from me? So again, just to emphasize, pre-rotation main use case is portable device. So this mostly apply to mobile devices. Okay, pre-rotation is a process of rotating your image so your swap chain matches your surface. So far, so good. Since mobile devices are handheld, you can have 4 different rotations. And as it happens, users tend to change them during the runtime as well. You need to account for that, otherwise your image would just get messed up. If you don't do it in your application, something else will do it for you. In mobile case, it's the presentation engine. If you don't do it and someone else has to do it, there is a very high chance, basically 100%, that you will incur a performance penalty. In here, I will also note that the identity transform is the device natural orientation, and that does not always mean portrait. On tablets, for example, it may be landscape or portrait, and it's not just how you think you will hold your device, it's the actual hardware property of the device that is not changeable. Okay, I already talked about rotations and transforms and like what is what. So you have the surface, which has current transform. Vulkan is not able to set that. You can only query that. This is what rotation is applied for the surface from the device natural orientation. Then you have the Swapchain pre-transform. This is what the application did to the image, to the Swapchain image, and you set it when you create the Swapchain. Again, if those two don't match, then the presentation engine will have to do the pre-rotation for you, which you do not want. Okay. Remember how I told all of the desktop developers to go to sleep? Well, in here you will very briefly have to get awake, to wake up, but just for a second. But now all of the mobile application developers should not listen to this slide. This is not for you. The title, suboptimal, why is it returned? You don't care. You got suboptimal, you recreate your swap chain. This is the way. But I'm still gonna tell you why. When you do VKQ present, there are two options. Either the pre-transform and the current transform match, or they don't. If they match, you're all good. There's no rotation necessary. You've already rotated your image, or you got lucky, whatever. It's just passed through to the display processing unit, and it gets on the screen. In the case it doesn't match, you now can have two behaviors. So the image gets passed to the surface flinger, which will query the hardware capabilities of the DPU if it supports the current layout and if it can pass through and just display to the screen. If it cannot, it will get back to the surface flinger, which will then set up the render pass, do the pre-rotation, I guess rotation at this point, do the rotation, and then query the hardware again. Can it present? Most likely, yes, you just did the rotation, then gets to the screen. That will always return suboptimal. If the rotation is supported, that does not mean that the current transform matches the pre-transform. It is possible for the DPU to be able to support the rotation, but because of Android CTS, it will still return suboptimal if they don't match. There's many reasons why Android CTS enforce that. But as the hardware changes, we will most likely have to think about changing that test in the future. There is literally just a single CTS, Android CTS test that is blocking us from that, but there is a very good reason for it. So no matter what, if you actually get suboptimal, you should always recreate your swap chain. And Windows people and all other desktop people will care about suboptimal as well, because that is what is being returned whenever you resize your window. Yes, but why don't people do it? Are they lazy? I mean, yes, developers are lazy, otherwise they wouldn't be developers, but that doesn't stop them from implementing other features. So that's not that. Are they incompetent? No, not really. So are we completely disconnected and we are telling them to do a lot of work, basically rewriting their whole engine to get benefits on just a single platform, and the work that we require them to do is extensive and can go wrong in a lot of different ways? Yeah, I think I think that might be it. So rewriting everything is an extreme project and a lot of work. But what if it doesn't have to be? Last year, we introduced something that we like to call just-in-time pre-rotate. We created it as a Vulkan layer that is already commercialized on some of our devices and even is being shipped as part of some high-profile games. The way it works is just before an image is presented, we just manually rotate it in software, just basic render pass. And as you can see on the graph, that can get you up to the 9% in performance improvement. Here you might want to note that many engines already do a bleed of the final image to the swap chain, which is a perfect place to do the pre-rotation. You already do the work, you can just rotate it as well. Basically free, and you get performance benefits. This combined with the correct management of swap chains shows consistent performance improvement on range devices and no noticeable performance drop on devices that do support scanner rotation. You may notice that the performance gains go up with the frame rate, which makes sense if you think about it, but it's still something that is worth pointing out. We have also another project in pipeline to simplify Swapchain even further, so you can care even less about any of that, but it's not quite ready yet, so maybe I will tell you more about that next year. Okay, now to get to the actual thing that people care about is the maintenance, when to recreate, how to recreate, and some common issues with recreation. So we did explain the logic of when to recreate, but as part of recreation, you always have to destroy Swapchain. There are two ways to recreate. One way will be destroy before you recreate, and the other one will be destroy after recreate, but both of them involve destruction. So let's look at the issue with the Swapchain extension spec. You are only allowed to destroy Swapchain when there are no outstanding operations on any of the images that you acquired. That involves VKQ present. Here, note that it doesn't mean that the presentation of the image has to finish. It means that the VKQ present has to finish, which is the transport from the rendering engine to the presentation engine. How can you know when that is done? Well, you can think to yourself, I'm just gonna call VK wait idle. That's gonna do everything, right? Well, yeah, as you can see in bold in here, wait idle only waits on commands that accept a fence. VKQ present does not. There's absolutely no way to know when can you destroy Swapchain when you are tearing down. So that's kind of a big hole, but not really. In every single Vulkan implementation, asterisk, if anyone knows I'm wrong, please do let me know, but otherwise, in any Vulkan implementation, just call VK wait idle before you destroy your Swapchain and you will be fine. Yeah. When recreating though, it's a little bit more complicated. So when to recreate? First of all, the failure cases, like the no-brainer. You did not manage to create your Swapchain, you did not manage to get your image, you did not manage to present your image because of whatever reason. Something went wrong. If your application is still recoverable, you might want to recover. Yesterday we learned that maybe you should actually crash and teach driver developers a lesson. Up to you. Another way to know when to recreate is when suboptimal is returned. I will repeat myself. Suboptimal is a success return code, but it means that your performance is not as good as it could be. If you care about your performance, if you get suboptimal, you will recreate your Swapchain. Again, mobile, mostly rotation, Windows, mostly resize. Yesterday, we also learned that some people don't get the warm and fuzzy when using Vulkan, so you might want to skip using Vulkan altogether for your recreation. You can just use entry points from your platform. In this case, Android hooks. I work at Samsung, I know mobile. But what it means is you can just get your windowing system. You can get the entry points from your windowing system of how anything change with your window, and then you can anticipate the need to recreate Swapchain even before it gets to the suboptimal point. I personally don't recommend it. I get the warm and fuzzy when I'm using Vulkan. But there's many issues with using platform hooks. First of all, thread synchronization. For some reason, I said Android synchronization. That should be thread synchronization. I apologize for that. Usually, when you get platform windowing events, you do it on a different thread than your rendering thread. So now you have a thread that is using the Swapchain and another thread that is trying to recreate the Swapchain, and you need to synchronize those two threads. Synchronization is never fun, so just like don't. Another reason is if you support multiple platforms, now you have to support multiple COV paths that technically do the same thing, but slightly different. And who wants that? Who wants divergence in their code? And the third reason why not to do it is making sure that you have 100% of cases covered and knowing when your entry points, your hooks, or whatever are called. For example, when we introduced fold devices, you now have a device that changes its screen during runtime. Are you 100% sure that your application that was using Android hooks accounted for it? Maybe, maybe not. Some people did, some people didn't. It's pain all around. Okay, how to recreate. So I just talked when to recreate. Now I'm going to talk about how to do it. File case, pretty simple. If you still can do it, if your application is somehow alive, recoverable, and you actually decided that you want to recover it, just recreate, done. Common mistakes when recreating. I've put in here 3 most common mistakes I have seen people do. So from left to right. The first mistake is trying to use an image from a Swapchain that was already destroyed. So in the picture, this is a logical order of operation that's wrong. You acquire image from the old Swapchain, you synchronize everything, you destroy your old Swapchain, you create your new Swapchain, and you try to present the image that you got from the old Swapchain. It doesn't exist anymore. It will crash. Or it might not crash, but it's not good. Your application will suffer. The second common issue is pretty much the same, but less obvious. You acquire an image from an old Swapchain, you create a new Swapchain and pass in the old Swapchain as a reference. You destroy the old Swapchain, and you think because you use the old one to create the new one that you can still use the old image. No, that is not the case. The image handles are not reused. The new Swapchain has new images, and you need to get the images, and you are not allowed to use the old one anymore after destruction. What you should do in this case is you should keep the old one alive until after you are done with the old images and then destroy. And the third most common issue is a very simple issue, is you try to acquire an image from a retired Swapchain. This is not allowed by the spec. So Swapchain Maintenance 1, it's a great extension. It helps with a lot of Swapchain issues, like the one with the present fence. So now you know when you are allowed to destroy your Swapchain when tearing down. It also allows you to defer the Swapchain image memory allocation, which can lower your peak memory usage. Our recommendation, the system integration group recommendation, and I'm pretty sure Android recommendation, is to always use this extension whenever you can. not a lot of devices still support it. Right now, according to GPU info, only about 25% of Android devices have it. In Android, it was first added in Android 14, I think. So if your engine targets a lot of devices, there's no way for you to use it. So what should you do instead? The way to recreate, you have two possible approaches. The first approach is to flush and recreate. This one does a full Swapchain teardown and then creates a new one that you will be using from this point on. The second approach is to create new Swapchain while the old one is still alive, and then destroy it old when all acquired images are released. Flush and recreate could be considered where memory is the main concern, as it has a low potential memory peak usage. But recreate and check is recommended when you care about the performance. And in 99% of the cases, it's the recommended one. So flush and recreate. Logically, it's extremely simple. You stop your whole rendering process, you sync everything, you're done with everything. Before you acquire the image, you recreate your swap chain, you then acquire image from your new swap chain, and there is no way to mix up your handles, your image is nothing. Simple. But that means a hard sync point. The whole thing has to stop before you're able to go on. Okay. A very common issue we have seen is that the VK error native Windows in use error is returned because the surface that you are using already has a swap chain associated with it. Usually it is caused by application somehow losing the handle to the swap chain, and it thinks it already destroyed it, but it did not. Some workaround, if that even can be called that, is to recreate the surface and hope for the best. On some of the Android platforms, it works, and therefore people think it's valid. I really hate that, and please don't do that. But if you need to get the game out of the door and everything is crashing and burning, I understand if you do. The real fix is to, well, fix your application, make sure that you never lose swap chain handles and that you delete before creation. So as I said before, the main benefit of this approach is the lowest potential memory peak usage, as only one swap chain will be alive at any given point. But again, if you can use maintenance one, this benefit is just no longer a thing because of the deferred memory allocation. Okay. So then we have, okay. Then we have recreate and check. That's the second approach. This one is more complicated. It requires you to do a lot of state tracking, and you might end up presenting suboptimal images for a little bit longer, and you can get higher performance, higher memory peak usage. And also, as a bonus, some tutorials have small bugs which can lead to even more handles being lost and all swap chain just being alive in the background forever. But the benefits are quite good. So first of all, no hard sync. You do not need to stop your rendering at any given point. You create your new swap chain whenever you want, and you can still keep using your old swap chain while the new one is being warmed up and everything. There's no theoretical performance hit here. This is the workflow that should be used on Windows whenever you resize your window. This is why it was created. This is why you are allowed to pass in old Swapchain when creating Swapchain. And just unless that wasn't clear, this is the one I recommend. We don't really have time for frame pacing. Sorry, it's there. It's pretty cool. Maybe look into it. I will just very quickly talk about the presentation modes, just so we are aware. There are 3 main presentation modes, one of which has 2 variants. You have the immediate mode renderer, which is not something you should ever use in a commercial device. It will have very high power usage and also may result in tearing and stutter and is awful. Then you have Mailbox, which I do not recommend using. Some developers are very tempted to use it because they think that, well, now my frame rate went up. Yeah, great. Now your whole thing is stuttering like crazy because your frames are being skipped. So did you really lose? Did you really win anything? And the third last one is the first in, first out. It's the prefer mode. It's the one I recommend, and it's the only one that is required to be supported by Vulkan spec. Then you have also a variant on the first in, first out, the FIFO relaxed, which may have some tearing, but will not skip frames, but still can be considered as stutter, as frames will be displayed for a different amount of time. Then I would go into what stutter is, how to synchronize, why not to do GPU synchronization, why you should do GPU synchronization, what extension you should use for it, how everything is now fixed and great, but you should care about latency. But as I said, no time. So any questions?
So I found the performance numbers on your just-in-time pre-rotate to be very curious. Do you have any idea why your app doing the rotation is able to do it more efficiently than the Android compositor doing the rotation? Because that surprised me a little bit.
Yeah, everyone is surprised by that one. It's because you set up in advance and you don't need to bounce around between the DPU and the surface flinger, and surface flinger already gets the rotated image. It doesn't need to. Yeah.
Ian might have a follow-up on that one.
Yeah. I can explain it. We can talk more offline, but bottom line, so Glus drivers on Android did the pre-rotation for you. And then for Vulkan, we decided, oh, we're pushing things up to the app. It's the app's responsibility. But the idea is that you can do everything, just slightly modify your shaders, and then it just all gets rendered properly the first time, like Glus drivers used to do. And then there's no need to do a blit at the end. No. Well, this is, yes. If you do pre-rotate, so I worked on WSI and did the initial spec and stuff, but also did the pre-rotation for angle. And if you do it properly, it's good. You don't see any problems. This is a shortcut that was talked about. But if you look in the angle source code, you can see how to do it properly. And we have a blog somewhere. But again, come talk to me if you want to learn more about it. Is that good, or? I have more thoughts, but anyway, but I know we're short on time.
On your just-in-time pre-rotation, are you assuming that the device always wants to be in one particular orientation? Not the device, the app wants to always be in one particular orientation?
No, we don't have to. No.
Because you were talking about like just doing a render pass at the end to kind of flip it. But if the app is like, if I'm holding the phone like this, it's in landscape mode. If I'm holding it like this, it's in portrait mode.
We fully support users rotating.
So, but doing pre-rotation, I'm going to have the orientation of the thing that I'm now trying to munge in my final render pass is going to be wrong, right? I've got a landscape. When I flip it to portrait, I need to show more top and bottom of the scene and less side to side of the scene, right?
No, this is a logical rotation. It's just how it's laid out in the memory. If that makes sense.
So if I'm looking at your car that you had there,
Yes, that would
If I'm-
that's what would happen if you didn't have any rotation and if the presentation engine didn't rotate as well, right?
yeah, but if I'm holding the phone like this, then I want to see the whole width of the car. If I go like this, I want to see not the whole width of the car, but I want to see part of the sky and part of the road, right? Like, so the content of my image is now different, so I don't see how it can be handled in a final render pass right at the end.
We should go do a whiteboard exercise. One thing I'll add is if you let the let the GPU do the rotation, you will always have a power hit, right? You'll take more power because you're doing this extra blit, and you may have a performance problem.
But I've got, the scene is now different. If I rotate, the scene is different. Like the content is different. Unless I'm drawing a square.
You're kind of
scene
doing
all
a
the time.
double,
No.
in your rendering code, you're kind of doing a double rotation. And I'd have to whiteboard it for you to explain it. We're not going to be able to verbally explain it real quickly.
Right, but I have to do that ahead of presenting the thing. I can't, or ahead of rendering. I can't do it after post-rendering. You seem to indicate you're doing it post-rendering,
Yeah, we do it before presenting.
right?
Yeah.
So his approach is going to require the power hit and maybe a performance hit, but not as bad a performance hit as if Surface Slinger does it.
If you do a pre-rendering?
If you do it during rendering time, you just modify the very last line of a
Yeah.
shader to.
So maybe I'm not being clear. Like, is the content of the scene not different?
The way we do it, you end up with the same content as.
No, but see, that's what I'm saying. So yes, the app is always treating it as one orientation. Like,
Yeah.
I want to show it wide, not short. So if I flip it, then now I got to look sideways on my phone, right? But I'm talking about an app where when I move my phone, I actually want to continue to look at it. So let's say I'm doing AR. So I don't, when I move my phone like this, I don't want to have to turn my head and look sideways. I want the app to now be showing different content.
That's different than the
Yeah,
pre-rotation
yeah,
concept.
okay.
Yeah.
It's like the short answer is if your app is scaling the viewport and changing the content like that, then none of this matters anyway because you've already done the work.
Yeah.
Provided that you were tracking the like current rotation, pre-rotation stuff. If your app is doing that, we won't, and you're like correctly doing that, we won't intercede. It's purely in the cases where like the orientation of the device has changed, but the app hasn't tried to respond in any way.
Yeah, we're in violent agreement, I think. I just wanted to clarify that
if you do the right thing
only
in
works
the app, our layer will do nothing at all
it
to
only
intercede.
Yeah, okay. Also a question, you talked about, sorry for monopolizing, but you talked about suboptimal when the transform is different. What happens on your platform when the size changes? Actually, not so much on your platform, but like, I don't know if the size ever changes on your platform, depending on the device. But on a desktop environment, the size changes all the time.
Yeah, it should also return suboptimal.
That's suboptimal as well, not a, what's the other one? Can't render or whatever. Yeah. So that would return suboptimal as well, size change. Okay.
Yes.
Okay.
I think this would just have to be the last question, I'm afraid.
So so the frame pacing part seemed to be too quick, going too fast. So do we have a one sentence summarization of the suggestions?
Yes. Use the Google Display Timing extension.
Okay, thank you.
And this one I can recommend to everyone without any asterisks because it's just, well, okay, small asterisk, but from what I know, it's supported since like Android early. Yeah, 2017, so like 8 years.
All right. Well, thanks for your presentation. That was great. Good.
If anyone is interested in collaboration with Samsung DevTech, here's the contact info. Thank you for listening, and thank you to Khronos System Integration Group for review and feedback. Thanks.
All right. Great.